In this video, we're going to go through some playing card problems. So we have our standard 52 card deck. There's a picture of it here in case you're not too familiar with it. You can make the picture bigger if you need to. But the standard deck has 4 suits: hearts, diamonds, clubs, and spades. And each suit has the cards 1 through 10. The 1 is usually called the ace, but the numbers 1 through 10 of those cards of each suit. And then we have a jack, a queen, and a king. And the jack, queen, and king are considered face cards because they have people on them, people's faces. And so our first question is, how many of the 52 cards are diamonds and how many of the 52 cards are face cards? So you can go through and count here, or you can think about the fact that this is 1 through 10, so we have 10 number cards and then 11, 12, 13 total diamonds. And for face cards, we see that we have 3 face cards of each suit. And there are 4 suits, so that's a total of 12 face cards. How many of the 52 cards are diamonds that are also face cards? So, looking in the diamond row, we see that we have 3 cards that are diamonds that are also face cards. So we have the jack, queen, and king of diamonds. Question 3 says find the probability of D. So D is the event that the card drawn is a diamond. So what is the probability of drawing a diamond? Well, we know that there are 13 diamonds out of the total of 52 cards. So 13 divided by 52. And then we want to write our answer as a simplified fraction. So we know that 13 times 4 is 52. So I can divide both numbers by 13 and get 1/4. Question 4 says to find the probability of not F. So this is going to be the probability that a card is not a face card. And this one up here, I'll write this out just to help you remember what this is. Probability that a card is a diamond. So looking at our picture, we have 40 cards that are not face cards, 12 cards that are face cards, 40 cards that are not face cards. So 40 out of 52. And again, both of those numbers can be divided by 4 this time. So to simplify the fraction, I would take out a factor of 4, and that's 10/13. Question 5 says find the probability of D intersection with F. So D intersection with F means a card is a diamond and a face card. So there are 3 cards that are diamonds and face cards. The answer for question 2 was these 3 cards, the jack, queen, and king of diamonds. So that would be 3 out of 52 cards. And that fraction cannot be simplified because 52 is not divisible by 3. Question 6 is to find the probability of D union with F. So this would be the probability that a card is a diamond or a face card. So let's look at our picture here. We have the 13 cards that are diamonds, plus we have 9 other face cards. The 3 face cards from each of the other suits. So 13 diamonds plus 9 other face cards. Or we could start with the 12 face cards and then add the rest of the diamonds. 12 face cards plus 10 other diamonds. Either way, we would get 22 total cards. So 22 out of 52, and both of those numbers can be divided by 2, so that's 11/26. So I'm going to write a little note here to help myself remember. 13 diamonds plus 9 other face cards. And question 7, find probability of D intersection with not F. Let's figure out what that is first. It's the probability that a card is a diamond, and then intersection means and, so diamond and not a face card. And remember, the apostrophe means not, so diamond and not face card. Okay? Probability that a card is a diamond and not a face card. There are 10 cards that are diamonds and not face cards. So that's going to be 10 out of 52 total cards. Both of those can be divided by 2, so that's going to be 5/26.